First keynote speaker, Guilherme Horta Travassos from Brazil. Actually, he is online from Valenciennes. Guilherme, please share your slide, and we are ready to listen and see you.
Okay. Have you seen my slides there?
Yes.
Oh, wonderful, wonderful. Well, so first of all, thank you so much for inviting me to be here. It's my pleasure to be talking to all of you. And thanks for Christoph Kolsk, a good friend and a wonderful professor that invited me, all the organizers. As I have said, I would like to be there, but it was not possible for me at this moment. I'm out of my country, doing some work abroad, and decided to stay a little bit in Valenciennes, pretending that I could work with Professor Christoph Kolsk a little bit more, but he's there with you. So anyway, I'm happy in any way. So the talk that I propose to share with you, it's maybe not pretty much regarding human-computer interaction, but I believe that it can represent a strong tool to support the research in the field. In fact, it comes from my experience in software engineering. I am a software engineer that play a lot of human-computer interactions in my projects, but as a user, not as a researcher. So, but anyway, I am trying to share this with you. So, the main idea that I have here is to discuss uh, some possibilities that we have to strengthen evidence regarding our findings and how we can share these with our practitioners and different interests in the results. So just to talk about me, I'm from Rio de Janeiro. I work at the Federal University of Rio de Janeiro. That's located in the city of Rio de Janeiro, in the state of Rio de Janeiro. A lot of Rio de Janeiro in my talk. But anyway, we are located in an island, as you can see here. For those that being in Rio can identify here the Sugarloaf. So we are far from Sugarloaf, and this is the technological center where we are located in Brazil. All right. So please think on visiting me in some moment if you have some time. And my main area of how to say study, it includes electrical engineer, software engineering, and mainly experimentation, empirical software engineering. That's why I am bringing to you this message. And then that is starting this conversation. So just to give you a little perspective about the main issue. So when we talk about software and we talk about software development, where several solutions of HCI are included, we need to think about three dimensions. The dimension of science, that's quite important. It's a sort of transversal to all the fields that intend to evolve knowledge. We need to think about the other dimension, that's the dimension of building things, where we have the engineering. And also, when we combine these two things, we have the products that we are going to build. Uh, in our case, I would like to define them as software technologies. Different, for instance, solutions for interaction, different components that can support one another behavior, and so on. Okay, think of science, and maybe if I'm being repetitive here, please forgive me, but it's just to give you my point of view. Uh, in the idea of science, when we think on science, we think in general observe the world, right? So we can think about observing the world by our own possibilities, perspectives, taking notes about what's going on, and then based on these annotations, we can draw possible conclusions or suggest some sort of behaviors that in one or another moment we can try to explore or experiment in a more, how to say, systematic way. So this is the normal way that we learn. This is the normal way that we can make our points or make your hypothesis, visible. And that's the idea that we have to evolve knowledge all the time. So we observe, we describe laws. Based on the laws, we can build theories, and then we have a cycle of learning that will give us the two, perspectives of the observation. One that's empirical, personal, and the other one that's experimental, replicable, that we can provide the results. So, doing so, we can do the experiments, and we can also build tools that will provide us with a lot of useful instruments to build our products. And these tools depend on the type of engineering that we are playing. Okay, so this combination of science, engineer, and the product that defines some reason the idea of soft engineering um, by the end of the 60s. Okay, not a long time, not a long time. We are really new area of science and engineering, and we've been working a lot to improve our approaches to evolve, produce, and evolve knowledge. Okay. And one of the things that it's interesting to see is that there is always a confusion about what's the software engineer does, in a sense that a software engineer, it does not just code things, but it builds things. So when we think about the software engineering, it's completely different what when we say software development, because we are talking about a really huge set of situations that involve different context variables, that we have a lot of influence from the processes, we have a lot of influence of the people there, and we also need to build the high quality products. So it's not just code, okay? So we have a systematization of work, we have a building process that we must follow. And I believe it is pretty much similar what we have in HCI, in a sense that if by one side in software engineering we are really concerned in how to construct the software, in HCI there is a really necessary and relevant concern about how the people or how the actors can use that software. So we have lots of things in common, and we cannot be separated. So in my mind, when I talk about soft engineering, not being ambitious neither pretentious, is that I see soft engineering as the big umbrella for the construction of software. Okay, and it involves not substituting anything, but involving all these important areas. And of course, when we think about HCI, we bring into the pot a lot of new concerns and skills from psychology, anthropology, sociology, and computer science. We cannot just say that we do not have computers. So think on that. We need to experiment. We need to evolve knowledge. We need to put things to work. But I know that is hard. Okay. We used to propose a lot of good things, interesting ideas, but most of them we are not sure if they are feasible, if they can really scale up, if they can protect the people, and all the risks that are involved in our technologies. So it's not easy to do these sort of things. So that's why we need experimentation. So we need to show, to evaluate all these features. Okay, and for playing experimentation, we need to have a really strong base in scientific behavior. Okay, we need to build theories. We need to validate these theories. We need to do the experimentation in large scale. To just observe one user or one human is not enough to conclude anything. So I used to say that soft engineering is big science, but I would suggests that software engineering and human-computer interaction mainly think about the contemporary software systems are big science, and they demand now a lot of experimentation. And then the idea of experimentation is pretty much regarding the experimentalism concept. Right? We need to be experimental, not just empirical. We've been empirical all the time, but we need to be more formal. We need to be more explicit, to give more explicit information about what we are doing, what are the conjectures that we have, the hypotheses, and the results that we are acquiring in the field. So that's one of the main reasons that we apply and use these tools is to acquire scientific evidence. We are looking for those description of behaviors that we can in some way claim that in that moment, based on our understanding and the knowledge that we have, that's the behavior that we can explain. So for doing so, we have the primary studies. And the primary studies are the primary source of evidence that we can have. These primary sources, these studies, they usually can be observational, exploratory, or experimental, in a sense that we always play in the two levels of the dimensions, the empirical and the experimental side. So this is important to understand that. And these primary studies, they are really important for us. We cannot give one step forward without having primary studies that usually follow a really well-defined experimentation process that we can see in the different strategies of study. I mean, case studies, surveys, action research, simulation-based, and so on, and controlled experiments. And these primary studies, they usually, and that's the way that we started to do them, usually we play them in vivo or in vitro, okay? The idea of in vivo is in the real world. So let's go there, let's run the study, let's see natural people, normal people, let's put the technology to work and see what happens. And in vitro, we are in the lab. So we, in some way, we make arrangements to play or perform that study, but since we are controlling so many things, it's quite hard to, to guarantee that all the observations that we have done, they make sense, all right? It's good, yes, it's good, but we are always have limitations on that. And we can use different perspectives to play these in vivo and in vitro studies. I am here listing just basic strategies that are quite common, I think shared by software engineering in HCI. In HCI, we have some little bit more, but we do surveys, case studies, we play action research, we do control experiments. In our case, in software engineering, it's quite hard to play to perform a control experiment. We used to have quasi experiments in a sense that it's not easy to organize a random sample of representatives to play the study. But the main issue is that we need to do these studies. It's important to have one. It doesn't matter which one of them. So, and we have a plenty of studies in the field, lots of studies. All right. So several results, observations that were collected in different moments, in different places, in different contexts, that they are there showing us results and behaviors that were observed in specific configurations. All right. So this is how we started. But next, I am still in the primary studies. We evolved a little bit because we realized that it would be possible to model the reality. And then we started to think about in vitro and in silico studies. It's an improvement and it's nice. And HCI can take a lot of advantage on that. In vitro studies, we have all my work, all my models are represented by a computer model of reality. Okay, I am not saying that all the models are perfect or real, but okay, we have models and we put the human to play with these models. All right? So this is the idea of in vitro. I have a person from one side and I have computers from the other side. When we play in silico, all the models, the human and the environment, are computer models. All right? So it's pure simulation. Okay, so in virtu, I could say that it's a quasi simulation, and in silico, I would say that's a pure simulation. And this is really nice because today we have computer power to produce these models, to play these models, and it can give us a lot of benefits. And then we can use this configuration of studies perspectives from in vivo, in vitro, in virtuo, in silico to build knowledge. Okay, of course, each one of them they present risks that we must be aware of that, and also each one of these dimensions imply in the level of confidence that I have regarding the results. Because, for instance, which type of study or which dimension of study the result can give you more confidence about the validity, an in vivo or in silico? You can answer for that. If I show you the results of two primary studies, one that is in vivo and the other one that is in silico, which one you trust more? It's a question for you.
Yes, I know. Personally, I would prefer in silico.
You prefer in silico? Interesting. But can you explain me why?
Maybe that second feature you listed there makes possible the creation of a large population.
But I
Virtual.
did not define the population of my in vivo study. I just said that it's in vivo.
Yeah.
All right. If I said, oh, I played an in vivo study with 1,000 participants.
If I want to repeat the studies, the study for an in vivo study, it would be difficult. It might be difficult.
Yes. Well, but
For
look, I'm talking about trustability, not difficulty.
trustability.
Yeah. In which result you trust more?
Again, I would trust in the second.
Oh, gee. Okay. That's all right.
I,
I accept that.
I'm biased towards
Yeah.
theoretical science.
But are you able to show me that the model that you are using to simulate is good enough and really represent the reality?
Um, Based on this assumption, I can sustain the affirmation. If I can present you the model, yes.
Okay, good. So
Uh,
see, these are the risks that I mentioned. I know, there is
I,
no there is no silver bullet here. I cannot claim that one is better than another
I,
because it will depend on several different variables and features. You know.
I said personally, I would prefer an in silico study, personally.
Okay, all right, okay, that's fine. That's fine, and we need your results. Trust me, we need a lot of these results because these are things that make the situation, better for us, and then we can have plenty of results on the table. As we can, for instance, think about the different strategies of studies that we find in HCI. This is just a simple set, and we see that just a few can play in virtual or in silico. I was not possible to understand how to do a control experiment in virtual or in silico with pure simulation. Maybe it's missing an X in that line based on what you said, but even so, we should think about that. All right, and the power of the evidence, it's stronger in vivo. It's always stronger in review. But of course, it depends on the configuration of the studies that we have. So these different dimensions of primary studies, I'm going to the secondary studies, just to wait a little bit. Uh, uh, uh,
What we
go, say something.
to test the functioning of a critical system, like the one that controls a nuclear plant, would you prefer an in vivo study?
No, but this is not the type of study that I'm saying. I'm saying the studies that this is software testing. It's a different thing.
Yeah,
I'm playing the studies that we have the participation of humans.
yeah,
Okay, for safety critical systems like that, you need to do simulation, you need to do model checking,
yes.
and you need to pray to nothing. That's wrong. Sorry for saying that. Okay, because
For
the
testing,
level of confidence, yeah, and again, risks. That's an important thing. You made an important point and a really relevant one. So we need to play with these. For some situations, maybe we cannot play in vivo, and you never play in vivo.
sure, of course.
And we need to control that. We need to be sure that we are guaranteeing assuring that these results are being useful and they are being well described, because it's not a binary situation. You know, our results, it has a depends on something. That result I can get if something happens. If I can guarantee a certain situation or configuration. All right? And that's what makes offer for us the first knowledge feedback loop. And when we play with these different dimensions, the threats of validity, the control, the risk, the cost, all right? And then we have plans of primary studies. It's fantastic. We are doing it very well. We are doing it very well. And we are maybe using it, can use it for learning. That's the way that we increase the knowledge. But the main issue here is that we have several primary studies in the field. Do you agree? Several results, different results. They are available everywhere for software engineering, for ATI. We have a lot of spread information. And these results, if we take a look at the results of primary studies, we can see that this result can be conclusive, non-conclusive, contradictory, confirmatory. If I have one study that is positive and I have another study that is negative, what's the result? What's the conclusion that I can have from these two studies? This is a big issue. And I cannot just combine the data to evaluate again. So I need to find the primary studies that we have, and we need to have a way to combine these results. So that's why we need secondary studies. Okay, now I'm just starting to talk, just to give you my viewpoint. So we do secondary studies. That's the second level, the next level of evidence organization to support the systematic finding of primary source and the systematic combination of the results of these studies, that I can use this combination of results to support or to strengthen the evidence regarding on a specific phenomenon. All right. So we can have different strategies for secondary studies. For instance, we can play aggregation, synthesis, or meta-analysis. For instance, if uh, we have a family of studies that we played ourselves, like you that said that like a simulation, that's cool. But if you have the results of five different simulated experiments, then you need to aggregate these studies. So you can go straight for the aggregation or synthesis or meta-analysis, even if these studies are quantitative. But when we do not have the studies in hand, so we need to do literature reviews. In fact, we play literature reviews for a long, long time. I believe, and I can assure that each one of you that are here listening this presentation, performed a literature review in some moment in your life. And probably it's likely that we played it unsystematic, in a sense that if you need to repeat that review, it's likely you are not repeating the same way. But one of the things that interests to us is to play systematic literature reviews. Okay, and we are doing this in the field, and the number of systematic reviews it's increasing, it's growing really fast along the years, and it justifies the idea of having tertiary studies. Tertiary studies are literature reviews, systematic, also systematic, that use as subject the secondary studies. Okay? So when we talk about secondary studies or tertiary studies, we are talking about similar type of studies. What change is the subject of the study. And it gives to us the second knowledge feedback loop. That's what enforces the way that we have to produce knowledge and the way that we can build new good stuff in the field. Okay, so I described the unsystematic literature review, the ad hoc process. We need to do it, yes. Am I claiming that we never can do it? No, we are gonna do it forever. But it's quite useful when we need to start up some basic process, when we need to look for something that quickly we can find, and we are not pretty worried about the completeness, or we are not pretty worried about the replicability of that process. Okay, it's quite hard, for instance, when we do an unsystematic literature review, that we can find those primary studies again, because we can simply forget to how we did the search, or we not more have access to one or another source of information. Okay, but anyway, they are useful, and then we can keep going with that. But what is really interesting to us is the idea of systematic literature reviews. This is hot topic, and this is something that can really strengthen the way that we play with knowledge and we produce evidence. Okay. So when we think about systematic literature reviews, and then we started to bring it to software engineering in 2004, when Barbara Kitchen, Emilia Mendes, I, and other folks from ICE, we started to discuss the idea of having the systematic literature reviews, borrowed from the medicine area, mainly. We are looking for a way to support the evaluation, aggregation, and interpretation. At least it's an intention of all available empirical evidence for a particular research question or phenomenon of interest. It means that we should have a way to organize a study that could collect all it's a dream, all of the available empirical evidence regarding a specific topic, and that we could use it to prepare an aggregated perception of the situation. And at the same time that we would like to have it, we also expected that this secondary study or this systematic literature review could present a fair evaluation of a research topic using a trustworthy, rigorous, and auditable methodology, in a sense that we needed to reduce the bias of the investigators, of the researchers. We need to have a really clear process about what was performed. Okay, this process should be replicable, and all of the decisions that were made during the process of analysis should be reported and in some way verified about its validity. Okay, so look at that, it's a little bit different. It brings a flavor of more effort to do the review. Okay, and these systematic reviews, they play two interesting things. They can be quantitative when we are trying to compare technologies, And this is a sort of a dream that we have, because if we have quantitative results, we could play meta-analysis, or it can be qualitative in the other side when we have information. So basically, what we can see is that there is a huge difference between the two words. We started playing systematic reviews. We started understanding how we should organize the reviews, how to produce the questions, how to define the different perspectives and features that we're expecting to evaluate the quality of that report, of the systematic review. And along this period, since 2004 until that we have currently, including the tertiary studies right now, is that we understood that we should calibrate or balance the level of the systematic reviews, because the initial dream borrowed from medicine was not able to apply or to observe in the software engineering field, and we cannot observe in any computer science area. All right, the medicine is years ahead of us regarding the organization and the description of the research protocols. But even so, we could play very well in this period. So we talked about quasi-systematic literature reviews. Why it's quasi-systematic? Because the systematic literature review, in the purest sense, it demands meta-analysis. In our field, it's quite hard to do meta-analysis. And I don't know about HCI. I did not play any systematic literature review in HCI yet, but those that I was able to work in a borderline, in a frontier of knowledge, they did not indicate to have enough quantitative results that can justify meta-analysis. Then we started we realized that lots of things to organize in the field. We started to do mapping studies. That is a sort of a lighter systematic literature review, in the sense that we can organize the field. But observing that most of the information and lots of evidence was staying outside of the pot, because in our areas, I believe that HCA, it happens in the same way. We have really relevant information that we can collect in blogs, white papers, description of companies, and so on. Sorry. So we started to do multivocal reviews. And in some moment of the time, we understood that the practitioners in the industry could not wait for an answer from a systematic literature review, because it takes time. So we brought to the field the idea of rapid reviews, also from medicine. In a rapid review, be careful. The term rapid is not because it's really fast, but it's because compared with a systematic literature review, you have more more facilities and agility. So you can play it in lesser time than a systematic literature review. And we have plenty again of examples of these sort of studies. All right. So all of them, they follow a really well-defined process that we have to build the protocol. We need to pilot this research protocol, to execute the search and play the analysis, and then next report. All right. So this is something that happens with all these. sorry, with all of these studies, secondary studies, and regardless if it's a quasi-systematic, a multivocal, all of them follow a common organization process, and all of them look for, in some way, play this set of steps. So I need to formulate a review question. I need to do a comprehensive high coverage search. For those that are more formal, I need to do a quality assessment of the studies. For instance, in the rapid review, we do not do quality assessment. All right. In the rapid review, the item 2, we can reduce the comprehensiveness of the search. But all of them we need to synthesize, the knowledge, and of course to interpret the results. So if we go to the field, and that was one of the things that we can be happy on, that is that the evolution of this scenario of investigation, it was really nice. And we have lots of good material that can give us interesting guidance on how to organize these studies and how to play these studies. Because look, it's an instrument, it's a tool to support our research. All right, it's a way that we can organize ourselves to see a phenomenon of interest, identify the population that where it's the information that we have, the intervention, uh, understand what we can compare, and then say what we would like to produce as outcome. So when we start to think about these products or the secondary studies in this way, doing this organization, we can think about the different levels of systematic reviews. All right. So the most strong systematic review that we can have is when we have the definition of population, intervention, comparison, and outcome. That's the PICO stuff. But when we have, for instance, quasi-systematic literature reviews, there is no meta-analysis. So the comparison is empty. When we do not have an outcome that we would like to characterize the field, so we play a mapping study, you know? So as more as dimensions we have, and more straight we can go, and more power we are going to have, and more confident we can be in the results. So that's something interesting that we can use to play these secondary studies. And of course, all these studies, they will involve a question, well organized, and the search. All right. So this is not the analysis yet, but I am looking for the sources of information, and they are spread in different engines. We are we are going to use the engines using tools to organize the output of these engines. So we have plenty of engines available, and the idea is to have high coverage. All right. So when we play with these engines, it will produce lots of suggestions of papers. And then we need to have a tool to help us on managing all this information that we can use. For instance, JabHat. It's an open source tool, amazingly good, configurable, that we can play a lot with it. And then after we do the search using the engines, we should think about complement the search by performing snowballing, backward, forward. For those that are not aware about snowballing is a strategy of search that, for instance, you take a paper, and then if you do backward, you take a look at the references that you have in the paper and go back. And forward, you look for those that cite this paper. So it is a really strong and powerful strategy to complement the search. And in my experience, in my research group, the best combination that we have is to use Scopus and next snowballing backward forward. All right, it works very well. And why what all of these means? Let me try to exemplify using a specific one of my systematic literature reviews. When we think about the protocol, when we think about the research questions, we are talking about research questions like this level. We have general questions that would like to understand or explain what's going on. And then, based on the questions, based on the expectations that we have about the investigation, we can define population, intervention, and outcome. Look at this level of systematic review. I do not have the comparison level. It's empty. Okay. Therefore, this is a quasi-systematic literature review, and that's my population. We are looking for these sort of representatives of my subjects. This is what I'm looking for. In the case, remember, our topic of interest is interoperability in context-aware software system. So I need to look for interoperability into context-aware software systems. That's my population intervention, and this is what I intend to produce as an outcome. So when I do this search, I can play with the engines, and it works like a filter that can separate all the possible participants of my study, and then I need, as a next step, to understand if that study, and then the effort starts, because we need to double check if all the studies they fit the inclusion criteria. And next, by reading those that we believe should be included, we need to understand if they do not attain the exclusion criteria. Okay? And now, all of these issues, they regarding, first, the type of studies that we are looking for and the acceptance criteria, because a secondary study does not expect that just one researcher perform it. Okay? So we use to work in 3 people at least for secondary studies to avoid the research bias. And in this case, it's necessary to have a criteria for acceptance of the paper. Okay? And it is quite nice to understand, because when you have this protocol well defined and look at the replicability of the study, it's not so complicated. At least look when we think about searching and when we think about including and excluding papers. All right. It's true that if we have 2 experts, it's like, for instance, when you have a physician and you show an X-ray result for both of them, these physicians are going to identify common things, but it's likely one of the physicians can see something in the radiography that the other was not able to identify, right? But it's part of the risk that we have in this sort of study. And then, okay, we have lots of good things here. So when we do play this thing, so the quality assessment is a really important thing that we have in the secondary studies. And then when we think about that, and not just the quality, but also the extraction of data, when we think about that, extraction of data must be planned in advance, in a sense that I need to identify those things that will help me to answer my questions. And I also need to define the criteria that will be used to validate the studies. Because when I think about that, some of the studies do not play, and it is something interesting that we need to deal with, is that when we talk about the quality of a primary study here, we are not making a judgment of the quality of that work, but we are making a judgment about the quality of that work to be included in our work. All right? So it's not a quality evaluation, but it's a fitness concern, and we can use it to define the papers that are going to be used in our process. And then after that, we can do the analysis. And then for the analysis, if we are quantitative, we should use forest plots, and then show how we can see and organize all these things, the interpretation of the results, and mainly to discuss the threats to validity, because we can face a lot of risks, and this risk will bring to us limitations of results. So the results used to be a synthesis about that situation, and it will happen for most of all of those secondary studies. All right. So we follow a really similar process. A piece of paper. When I was preparing this presentation, this paper has been published in Transactions on Software Engineering from Barbara Kitten and her group. And it offers a really nice discussion about this overall thing that I said before, and offer lots of suggestions on methods and strategies that you can use, not just to prepare the systematic review protocol, but also to evaluate if that protocol is okay and the report is okay. So I would suggest you, for those interested in that, to take a look at this paper because it's quite nice. So,
Yes.
software literature systematic reviews, they are nice, they are wonderful, but they are tough. they they demand a lot of time, a lot of effort from our groups, and sometimes this is not enough. It is not adequate when you need to give answers to the practitioners. That's something that we could observe in our projects with the industry. So no one can wait 1 year for an answer, you know, in the industrial context. And that's from where we came with, I mean, the community came with the idea of rapid reviews. Okay? The rapid reviews, it's an emerging approach in evidence-based medicine that's used to quickly answer questions about a treatment for some patients that is in risk. So one of the things here is that a rapid review is not intended to answer our research questions, but they are aimed to answer the research questions that emerge from a practical problem that comes from the industry, that comes from a real problem that we are having. Okay, and that's one of the things that we can do because uh, we have a reduction in time, we have a reduction in, we have a simplification of the protocol, and we can also play very well, okay, in answer things that we have low risk for those situation. Like I remember the example on the simulation. Oh, you cannot simulate a nuclear plant. Yeah, you cannot do a rapid review for something critical. All right. So, but you can do a rapid review for answering most of the questions that we have, mainly software engineering, because for several situations, the risk is 100%. So, if we can reduce the risk to 20%, I think it's much better than if you are, playing in the industry, rather than to have a 100% risk. Oh, and that's really nice because we are doing a lot of things well. Systematic reviews can simplify a lot our work. Uh, it can give directions about if it could be feasible to play a systematic literature review or not. Because sometimes you play a rapid review and you can understand that it does not work to invest more effort on that direction. And we can have a wonderful tool that can support mainly our master students to play quickly their literature reviews because it helps to organize the research protocol and it helps to promote the way that we can do the search. So the idea here is that we have the rapid reviews. But one of the differences that we observed for rapid reviews is that they are intended for the practitioners. The practitioners hate those idea of formal models and everything. So we need to have a quick way to communicate the results of systematic reviews. And one of the differences that we have for rapid reviews here is the way that we report the results. We used to use evidence briefings. Evidence briefings are a really nice way to communicate the results of a rapid review. They can be quickly accepted by the practitioners. This is this example of evidence brief from technical depth. It's real. It's being shared. And it's a result of one of our research, collaborative research there, and it was demanded by a company. So it helped a lot to spread the information among them, and we could play this rapid review in 5 months, what was really amazing compared with the other systematic literature reviews that we have performed. Okay, so if I think about this overall thing. So we started with systematic reviews, 2004. We came along this process of secondary studies. We also have tertiary studies right now. We can see that lots of things have been learned, and we can do lots of things more. So we can use this approach and the idea of to be systematic to support the strength of the evidence that we have in the field. Software engineering HCI, it shares a lot of common things. We play a lot of primary studies, and to use this as a tool to organize our findings could be a really nice way to think on how to improve or to grow, to make more powerful the field based on science. All right? So based on that, we evolved. That's true. It's also true that this is not a silver bullet. Please, uh, it can help us a lot, but it demands some experience. It demands the organization of good teams of research. Okay? Rapid reviews become a reality now for us, so it's quite nice, and mainly because it can help in our interface with the practitioners in general, the industry. Uh, and of course, we need to think about the different strategies of studies because secondary studies, they are really hard to be undertaken if we do not have the primary studies. And the primary studies, when we think about software engineering and HCI right now, it involves different variables. It involves different contexts. It involves contemporary solutions. It will demand a lot of things. Like for instance, we need to be able to do a lot of planning on biometric measurement in software engineering that influences HCI. Uh, we need to do a lot of experimentation with human computation that it's really hard to dissociate one perspective from another. And we also need to think about how to automate the systematic literature review because to do it by hand is not an easy thing. All right. And also we need to play a really nice thing is that we think about quantitative, we think about qualitative, but how I can combine quantitative and qualitative studies results? Now, that's why we have the research synthesis in software engineering. So we have the structured synthesis that you can combine these results and make and build support the building of theories with the findings. All right. So this is what I brought to you. I think I am still on time. Uh, I am open for questions. I can make these slides available for those that are interested. I can send it to Professor Kolke and then he can distribute to you. And I'm open to discussions and conversations about the topic. Thank you so much. Thank you very much.
Thank you.
Any questions? Yes, please.
Thank you very much, Guillaume, for your very complete and inspiring presentation about this very vast domain. I have a question, the first one.
Uh-huh.
Currently, in industrial and academic projects, is it possible to help project managers and in fact also PhD supervisors because we are, well, of us here are concerned by the possibility to use the studies. It is possible to help us to help also the project managers to decide about which kind of primary studies to perform. And you gave us different ways, and you mentioned also the Segres method, and is decision-making method possible in this domain?
Oh, Professor Cox, thank you. Yes, it's possible. It's possible. There are one or two initiatives on this direction, simple ones, but mainly for academia, not for industry. Okay, so not as something that you can see explicitly for using in the industry. It's true that if you take a look at those maturity models like a CMMI level 5, you can see a lot of experimentation on that for primary studies, all right? But not for composing the aggregating the results of these studies. Okay, it's quite hard to see. Uh, I don't know my experience. I played systematic reviews for the industry as a demand. So I was contracted to organize these protocols for big companies. But for really strategic fields, so futurist things. All right. What I can see in my experience is that mostly of the problems that we are facing now, we are being able to solve with rapid reviews. Okay, because you have in the rapid review you reduce the level of confidence of the answer, but you do not face risks for the company because, as I said before, they knew nothing and they start to know something. And then this is really important. All right, this is really important. But I understand that you are looking for a sort of a model to drive the decision about one strategy or another. Is that?
Yes.
Yeah, no, we can try to build one. No, I did not see something really useful yet.
Well, in certain project, it's very strategic to uh, to to have a knowledge to understand everything, each of the existing methods in the considered domain. I think
Yeah,
necessary in the space domain. The nuclear one was mentioned too and it's very strategic, but we know that also there are different constraints in the project, resources, financial constraints, and so on. So decision making, it's necessary.
uh-huh,
We have
yes,
the possibility to use certain of the methods you
yes,
mentioned,
yes,
certain voilà, the rapid methods instead of the classical systematic one. And
yeah. But I see that an important thing regarding these guidance is that not just to choose the strategy, but is to be able to describe the problem. Okay? Ou seja, is to describe the research question. What's the question that I would like to answer? Because the question that will give you some really good guidance about to where to go. Because depend on the questions, if you need to take a look at the past, then probably you need to play a survey. If you need to repeat a phenomena, then you need to play an experiment. So you know what I'm saying? It's quite nice, but this model can include all of these. That's really nice. Yeah, it's a good suggestion.
for instance, in your response, for instance, the necessity of a good description of the problems is a criteria for this decision making. Is an example of a good criteria, which
Yeah,
can totally critical for a company or for PhD supervisors.
yeah.
Like, indeed.
Yeah, this is a powerful tool. It needs to be tailored for each of the situations that we have. If we are doing research, PhD research, master research, if we are playing the industry, even for the primary studies. So it's quite nice. We can think about that. That makes sense.
Thank you very much.
Yes.
Yes, please.
Yes, I'm Dorian Gorgan from a technical university in Cluj-Napoca, Romania.
Nice to meet you, Dorian.
Thank you. Uh, we are involved in computers engineering, computer science, and in your presentation you specify, you make a relationship between human-computer interaction and software engineering from engineering point of view. And you specify that computer-human interaction or human-computer interaction concern mainly on user interface. I want to ask, it was a slide about this, and I want to ask, behind the user interface, there are some interactive components, there are some data structures, there are some knowledge. Who concerned about that? It's a subject of software engineering, or it's a subject of somebody else?
That's an excellent question. Thank you so much for making that. Well, we have discussed this for a while in different projects that we started. We started a project regarding context awareness systems some time ago, and interaction was a really how to say important player in that project. Regardless who could be interacting, you know. When we think about contemporary software systems, and then of course we are not thinking about the monolithical solution for things, but we have the solution spread everywhere, like IoT, for instance. Where is the interaction? Who interacts with what? Where is the human? The human is in the loop, or the human is into the loop. All right. So we started to be pretentious and then to define that we are not talking about the human-computer interaction, but we are talking about actors-computer interaction, where the human is one of the possible actors. An important one, for sure, an important one, but not just the actor, you know? And then all these pieces of concerns, I would say that they spread, throughout the project. I cannot assure to you that it's software engineering or human-computer interaction, but I would say that's a problem of interaction that we need to work out with engineering. Because it's a really huge problem, because the interoperability, for instance, that's the example that I showed, the systematic review. It's an open question. We talk about interoperability in a so easy way, but we forgot to define what interoperability should be and how the different parts of the system should interoperate with each other. There is a semantical issue on that we need to work out. We need to see, for instance, the interaction. We mean, the human is interacting with the system. Maybe the human is promoting events that the system can perceive, and the human has no idea that it is interacting with the system, but it is. And then it's something that it's really hard. It's a good question, but I don't know if I answer you. Maybe I talked more than I needed, but I share the same perspective. We play a lot of projects. Yeah.
My question was from designer point of view, engineering point of view. Who has to be concerned on this subject of what is behind?
I think, I think both. I do not see my project. I do not see my project as a pure software engineering project.
Yeah.
My projects all of them are multidisciplinary. So you have plenty of different people. We need to have different experts. And of course, we need that someone explain to us the interactions, that we as engineers can be able to model this interaction and guarantee that it's going to, work in the software.
My question was related with the second one, because new subject and domain emerged, and For instance, machine learning, artificial intelligence, big data, IoT. So the question is, the developer, the designer of computer-human interaction component and interactive component have to have skills in this and knowledge in these domains, or just somebody else?
That's a nice question too.
Because in fact,
Let me try. Let me try to explain a little bit from the experience that I have from my projects. So those I have some designers that are not from computer science, designers, okay, that help us to design the prototypes of the devices. They have no knowledge regarding computer science. They have no knowledge regarding human-computer interaction, but they have a lot of expertise in how to produce good parts, how to produce, those things. But when we put them together with those that understand the HCI and that understand the engineering process, it grows. It combines. I do not see that a regular person can be able to internalize all the knowledge that you mentioned. It's quite complicated. We can have a bare. This is my opinion. Sorry, we can have a bare perception about all these things, but when you put machine learning, data science, IoT, interoperability, software components, this is a really complicated thing. I see, at least in the current situation that we have, and mainly think about the curricula that we have in our universities. We do not teach in that way,
Okay.
at least from my experience.
Thank you.
Yeah.
I would like to continue on the exact same point. And
Sorry, I am not listening to you very well. Could you speak up?
Closer. Yeah. I would like to continue on the exact same point. And I'm pretty sure you have a lot of experience in this. And so when you said you bring in people from design and people from computer science, HCI together to work in the same room. A good strategy to do this process of gathering these people is it to let each one brainstorm in their part and then bring the ideas together. So the bringing them would limit what's not possible, but after the brainstorming, or do you bring them all together and brainstorm all together about all the sites?
Yeah, that's an interesting question. It's Yusuf?
Yeah.
Oh, hi. Hi. Thank you for the question. Well, all what you said happened. We do brainstorms, okay? We do a lot of lean strategies to design. We define personas. We paint the scenarios. We describe. So we are immersed on the discussions about the project. We need to use different strategies to put, because the product is the focus, not the solution. It's the product. Why I need that product? Who is going to use that product? How it's going to behave? And who does not mean, again, human, but actor. All right. So it needs a lot of things, and one of the issues that all of the participants of the projects are also subjects. So when we build a device, it's a pity that I have no one with me here to show, but we just built an oximeter IoT. So we prepared all the parts in the printer, the 3D printer. All right. So how they know that it's okay? Oh, they wear the device. They feel. We measure. Okay? We collect the information. Then we we keep in groups and we brainstorm about, okay, how we can evolve that, how we can change that. But it's a really, how to say, evolutionary and incremental way of developing. It's a lot of agility involved in the process. But it's completely different from all the life cycles that we have in regular software engineering, for instance. It cannot be. It's different. The language of doing, if I can use these expressions, the language of doing is not the language of software engineers, it's not the language of the design, but it's the language of the project. So they must be, and one of the things that is quite important that I see in this context is to assure that all the participants of the project share the same viewpoint, the same perspective. Okay? About the object. That for me is the most important thing. It doesn't matter if they understand about PHP, Java, or Windows or whatever, but it's the product. The product is the focus. It's the thing that's going to be engineered. So that's the way that we play there. But okay, brainstorm is nice, focus group is nice. We play lots of these things. All right?
Guilherme, thank you for your very good comments. Cristian Mihăescu, co-chair of this session.
Okay, all right.
It's a pity that you are not here, and we could not continue our discussion during the coffee break, which is already ending. Thank you very much for your presentation.
Thank you. It was my pleasure.
We are sorry that you are not here with us. Take care and.
All right. Thank you all. It was my pleasure. I'll send my slides.